Hello, this is Hemanth. As per the assignment, in this session, I am going to explain Laplace of function t, that is f of t equal to t. So let's start working on it. Laplace of, as we all know, Laplace of f of t. F of t as a function of t is integral of 0 to infinity minus e to the power minus st into f of t dt. So in this, we are going to find out how Laplace of this function f of t is equal to t. So Laplace of t is equal to integral 0 to infinity e to the power minus st into t dt. So as we all know, this is in form of integral u form. So I'm just writing the not writing the working formula. I'm just writing u into integral v minus integral du integral v. So let's take t as u and e to the power minus st as v. As you know, from Euler rule, we have to take a exponential as a second function. So I'm taking u as first function. Sorry, t as first function. So e to the power minus integral from 0 to infinity e to the power minus st into t dt is equal to u t into integral e to the power minus st minus integral or d 1 as dt by dt is equal to 1 into integral v e to the power minus st dt. So solving equations, t minus 1 by s is integral of e to the power minus st is equal to minus 1 by s into e to the power minus st. As we have taken limits as 0 to infinite, minus so no need to write 1 here, integral of e to the power minus st, as you all know. I'm taking out 1 by s outside of the integral as it is a constant. Integral e to the power minus st dt. So minus into minus plus. So we have to substitute the limits, nothing but substituting value infinite in t and subtracting by substituting 0 in the value of t, so which is so let's take some minus t by s into e to the power minus st. So we can add a in the place of t, which we just did. Plus 1 by s into so this we can write it as integral 0 to infinite e to the power minus st into 1 dt, which is in the form of Laplace of 1. So this we can write as Laplace of 1. Oh, so I skipped writing this term 0 by s into e to the power minus s of 0. Anyhow, it will be nullified as we are multiplying it with 0. So I just skipped that term. So we are substituting this value here. So as a tends to infinity, as it is e to the power minus infinity, let's assume that, like multiplying s with infinite is also infinite. So e to the power minus infinity, as you all know, it tends to 0. So anyhow, this won't affect much because as we all know, the graph of e, it is much stronger than this term. So the rate is much faster in this term, so it obviously tends to 0. So this whole term is nullified now, means its value is 0 now. So we are left with only this one term, 1 by s into Laplace of 1. So I have to solve this term now. So Laplace of 1 is 1 by s into integral 0 to infinity e to the power minus st of 1 dt. So 1 by s into integral of e to the power minus s, as we know, minus 1 by s into e to the power minus st to infinite. So minus 1 by s square into applying the limits here, e to the power minus st, where let it be t, the value is infinite here, minus e to the power minus s into 0. This should not be written in this way. Let's write it again. 1 limit a tends to infinity e to the power minus sa. As we know, e to the power 0 is equal to 1. So this is the same concept which we use here. So e to the power minus sa, where a is tending to infinity. So this value will be nearly equal to 0, will be almost equal to 0. So you can take it as 0. So 1 by s, and what is one more remaining term is minus 1 here, e to the power 0, and this minus sign, 1 by s square is equal to plus 1 by s square. So we have to remember this, this is only when s is greater than 0. So this one because we are multiply s is also greater than 0 here and here. So remember this, s is greater than 0. So that's it.